So on this lovely day, we're going to talk about angle pairs, angles that have special relationships. They're like boyfriend, girlfriend. So one of them is adjacent. We're also going to talk about vertical angles, complementary angles, spelling is important here, supplementary angles, and finally something called angle bisector, which creates a specific special dealio. All right, so let's talk about adjacent first. Adjacent, the quick way to say adjacent is next to. Now, many of you probably already know that. It's an angle that next to or next door angles. All right, however, officially, they are angles, golly, I don't. So angles that are next to each other and that they have to share a vertex and a side. So let's see a diagram of what that might look like here. So here would be a good example. You have this angle right there, and then this angle right here, angle 1 and angle 2. Both of these together are adjacent. Angle 1 and angle 2 are adjacent. And we can abbreviate adjacent with ADJ. And you can just say ADJ with the symbol angles, like that. Now, a non-example is probably important here because if I were to diagram this and call angle 1 right here, and then all of this is angle 2, these two are not, because angle 1 is inside of angle 2, so they're not adjacent. But Swenson, they share a vertex and they share this side, right? This side is the same, the side for both of them. Yes, that's true, but angle 1 is inside of the other angle. So that in this case, we would not say adjacent here. Neither would I say adjacent here. Like these two angles, yes, they're kind of close to each other, but they don't share a vertex. Again, this one, this vertex is here, this vertex is here. So, yes, they share a side, but they don't share a vertex. So just beware of that. They have to be next to each other, sharing a side, sharing an angle, a side and a vertex. All right, vertical angles. Vertical angles make an X. They always make an X. All they do is share a vertex, and it looks like this. The best to have a diagram over here. So, in this diagram here, angle 1 and angle 2 are vertical angles. So, they share a vertex, and they make an X. Share a vertex, and they form two lines. They share a vertex, and they form two lines. Question is, well, what if they were left and right? Are those also vertical angles? Yes, that would be another example. So angles 3 and 4 here are vertical to each other. So in this case, I would say angle 3 and angle 4 are vertical, and angle 1 and angle 2 are vertical. However, we would not say that angle 1 and angle 3 are vertical. Angle 1 and 3 are actually adjacent. They actually even have another relationship, which we'll look at in a minute. So these are adjacent. 1 and 4 are adjacent. 1 and 2 are vertical. 2 and 4 are adjacent, etc. In this case, I have an angle 1 here and an angle 2 here, but because it doesn't form like a perfect X, we actually end up getting, here's a perfect line, but this is not a line, that's a ray, and this is a separate ray. So boink, it bounces off. These are not vertical. They were not vertical. And neither are 3 and 4 in this case. They're not vertical because they do not form just two lines. Straight line here, straight line here. Nothing else going on. No bouncing happened at the vertex at all. Let's go ahead and scoot down. One thing here, vertical angles are going to be congruent. Vertical angles are going to be congruent. All right, it is important that you spell correctly because this next one, complementary angles, Do not spell it C-O-M-P-L-I. Do not spell it with an I, because if you are spelling it with an I, what you're saying is that this angle says nice things to you. Oh, nice hair today. Oh, wow, you're so complimentary. Complementary means to complete. It completes something. So some people, if you do a double misspelling here, complementary angels, these are like angels that come and tell you how pretty you are, okay? That is not what we're talking about. We're talking about an angle that completes another. Like my wife is my complement. She completes me in a way that I could not do. You know, I couldn't be a father without her as my mother, as a mother, not my mother. Weird. Okay, so there's an act of completion. You know, so I would have a messy house, and she helps me become the man I'm meant to be. So, in a sense, she is completing me. Not saying that if you choose a life of singlehood that you are not complete. That's not what I'm saying. I'm saying for the particular task that I've been called to, I need her. Okay. Definition. What are complementary angles? Complementary angles are any, learn to spell, two angles whose measures sum to 90. Any two angles whose measures sum to 90. Again, if it's helpful, I like to sometimes remember, well, how do I know what it adds up to? Well, if you draw a little itty-bitty line right there, you can see the 90 show up right there. So that might be helpful, because complementary, supplementary, which one's which? Well, complementary is the 90 degrees. They sum to 90 degrees. Now notice what we're not saying here. They do not have to be next to each other. They do not have to be next to each other. So a diagram, a pair of the most simple way people draw it is like this, where I just have two angles right here, and then you put your right angle. Oh, okay, great. So angle 1 and angle 2 are complementary. 100% accurate, this works. But they don't have to be adjacent angles. They do not need to be next to each other. So if I were to break up angle 1 and 2, oh, how sad, it's a bad breakup. So they're broken up here and here. And now for the case of a different diagram, 3 and 4, these are still complementary. Because if I were to put them next to each other, then they would make a right angle. So this one could be living in China, this one could be on the moon, doesn't matter. As long as when it's 30 degrees and 60 degrees. Oh, 30 plus 60 is 90. Those two are complementary. Now, we visualize them oftentimes adjacent like this, but again, they can be separated by millions of miles and millions of years away. Okay. Supplementary angles are... So supplementary angles are any two angles whose measures sum to 180. Again, they could be next to each other, but they don't have to be. So if I were to draw this scenario here, where I have a straight line and then something coming off it, well, look, angles 1 and 2 are supplementary. But again, like I said, one could be China, one could be in the moon. And in this case, as long as they add up to 180, angles 3 and 4 are also supplementary. They don't have to both be, one be obtuse, one be acute. They could both be 90. That's fine. So this would not be the case if you had something like this, because clearly they don't add up to a single, they don't add up to a straight line. They have to add up to a straight line. And neither would this be either if I had 3 angles inside. 3, 4, and 5. I would not say these 3 are supplementary. It's just a pair of angles. I mean, you could make an argument that there is a pair of supplementary in there, just not the numbers 3 and 4. So what does bisect mean? To cut in half, or to actually literally to cut in 2, but in 2 pieces that are the same. So if you have an angle bisector technically is a ray or a segment or a line or a plane, technically. It could be that as well. That cuts an angle into two congruent angles. This is the exact same idea as a midpoint, right? A midpoint divides a segment into two congruent segments. So instead of being one-dimensional about a line, this is two-dimensional. It cuts a two-dimensional object in half. So it's a ray or a segment. Technically, you could say line or plane or anything else like that. That cuts an angle into two congruent angles. So if I have an angle right here, A, B, C, and let me clean that up. So, and then I cut it in half right there, such that this angle is congruent to that angle. Then, let me rename that one BD, maybe, BD. So BD is the angle bisector. And in this case, BD is a ray, is the angle bisector, because it cuts the big blue angle in half. All right, this is actually a postulate. It's something undefined here, but the sum of the measures of angles that form a linear pair is 180. So you have to figure out, well, what the Gehenna is a linear pair? Well, a linear pair is this. They are supplementary angles that are adjacent. Often when we think of supplementary angles, we think, oh, this is supplementary. No, technically, angle 1 and angle 2 are a linear pair. They are a linear pair. Why? Because they are a pair of angles that make a line. A pair of angles that make a line. There we go. So when we put them up against each other, a line is formed. So turn the page and let's look at one example up here, trying to solve for y. Now, as we set up an equation, remember that we don't want to set up an equation that uses the letter y and letter x. So I'm not going to try to equate those two, because that's too many variables in one equation, okay? So what are my options? Well, instead of using those two there, I could use another pair. For example, here. This one is vertical to this one. So since vertical angles are congruent, my equation can be this: 6y plus ochito is equal to 7y minus 12. So another way to look at it is if we rotate it like so. So 52 degrees plus 6y plus 8 would equal to 180. So we could also do that. It would be more work, slightly more work to do it that way. 6y. And using the idea of vertical angles are congruent, to find out x, I can say 52 is equal to x plus 42. Now, we do have to solve those, but one of the most difficult part is setting it up. So I just want to make sure our setups are good right now. All right.